So yeah, I think we'll kick this off. People will probably trickle in, but appreciate you all coming. Very much looking forward to this discussion. This has been a phenomenal summit so far. I think a lot of the themes here we're going to. I think there's a nice continuum from the keynote this morning, or the initial panel, the kind of all panel around themes of how we collaborate, stakeholders, do we harden partitions between and kind of very clearly define the roles of an owner, of an architect, of a general contractor, of a manufacturer, or are we going to start blurring these lines? Are there going to be new configurations of skill set and domain expertise? So I think we're going to explore those topics, and I'm joined, have the fortune of being joined by industry experts, and I think glimpsing also at a future of how this industry can transform. I think that the conversations so far have been led a lot around how the general contractors or our roles will start to build new companies or focuses internally, but I think there's opportunities to learn from other industries and this sort of first principles approach, and maybe create new configurations of skill sets and people. So I'm very fortunate to be joined with Spencer Paget of Ghost Factory, who literally deploys manufacturing, and I'll let the panel introduce more in depth of their company profiles. But I knew Spencer previously of Icon, so 3D printing as a manufacturing technique for homes. I think sort of maybe would be several years ago when it launched, is sort of thinking sci-fi, and now the conversations around additive manufacturing. These are these kinds of things where I think we mark what is the future, what's sci-fi, and then we can make certain realities happen. So now at Ghost Factory, we're really understanding. He's really understanding the flow of logistics and what needs to be produced where. And then Walter Stender, who has of Silver Creek Modular, but has 30 years of true industry domain expertise. When I say industry, I mean aerospace, automotive, other manufacturing. And I think these conversations have come up. Well, we're just going to build buildings the way they build cars and airplanes, and people have pointed out that a plane and a car is a very different product than a home or bespoke housing. And even if do we have to pick a certain size box, and that's the answer. I think there's still an enormous amount to be learned from industry and other industries, and not just kind of cherry pick pieces and parts, but why they actually work. So I'm John Cerrone. I'm with Shop Architects in New York. It's less important, but I'll Spencer, if you want to give a little more kind of context of your.
Yep, sure. Yeah, Spencer Paget, CEO, co-founder of Ghost Factory. Like John said, I come previously, before starting Ghost Factory, from Icon, where we produced. I was the head of the design and construction team for Icon for several years, and so 100 homes for Lennar, a bunch of different things, a couple hundred buildings total that we produced using that form factor. Ghost Factory grew out of that experience there and needing to provide the rest of the building, especially the interfaces where advanced construction methods were meeting industry and tripping up. And so Ghost Factory was originally meant to be able to finish the rest of a 3D printed building, but there's obviously application everywhere. If you look at our website, if you look at LinkedIn or anything that we post, you'll see a lot of cold form steel. But we are not just a cold form steel manufacturer at the point of need. We are an industrialized construction capacity provider. We have a series of boxes. Our boxes are controlled by software. We go to the point of need and we execute wherever that is. So we're currently doing projects, a couple projects for the Department of Defense. We're doing disaster recovery in the Palisades. We are building residential and hospitality projects in the U.S. and responding to places like Venezuela and the Pacific Theater, hopefully here in the next several months. So we're all over the place, but glad to be here and looking forward to the conversation.
Yes, good morning. Walter Stender. I work for Silver Creek Modular, which is a private equity-owned corporation. We are an aggregate of various industries. We have site work, we do engineering, and we build buildings, or produce buildings in a factory. So my background, I'm very, very blessed to have worked in a wide range of industries. I've worked in aerospace, I've worked in automotive, I've worked in nanotechnology, and I've worked in semiconductors. I've been blessed to work with scientists and engineers and manufacturers around the world. And so I'm very excited about this opportunity because I do believe there's many, many things we can do in our industry that are already done and proven in others. Believe me, cars and airplanes don't have much in common other than wheels and metal, but they have very, very common practices, especially on the design side.
Great. And the previous panel that I attended, there was we didn't wait till the end for Q&A. So I do encourage, as these things come up, I'll obviously have questions that I'll keep it moving. But if people have, if something is brought up and there's a question, raise your hand, and I think we can sort of field them in real time, which is more fun. Well, that first question, I mean, what is our opinion of, like, do we keep the stakeholders we have? Is it a matter of more clearly, like building stronger kind of siloed walls around stakeholders? Does the owner really need to stay in the lane? They define the problem, they're going to provide the money, and then hands off around the design of the product. Do contractors own the facility and the coordination of this, but not getting involved in the manufacturing? And do we want to kind of harden these and really define the interface or exchange of information, or do we think that there's going to be new collaborations and maybe new types of entities or companies formed to address this?
Yeah, I really like the way it's organized right now. From my perspective, I've done land development in several regions. I've done stick-built home building across the country in the Bahamas. I've done manufacturing, and I work with a lot of architects, right? And I will tell you that as a manufacturer, I don't price in the risk of land development. I don't want to, right? And I think the general contractors, there's general contractors, which I've been. You're looking for a solution that will maintain your schedule, maintain the budget, and serve the client and the project well. You don't need to be worried about setting up a factory and executing if you want to use industrialized construction. So, my sense is that there will be projects that are organized in certain ways depending on the speed and the location and the need. I'd say that the lines, as a Marine, so I talk Marine Corps kind of things, but like the lines are defined by the mission. Are you a design build firm? Are you taking a set of plans from the Department of Defense that they've already done and executing them very quickly? Or do you have time to actually plan? So I think that in my particular perspective is that I'd love everybody to specialize, but also be open to blurring those lines when necessary to accomplish whatever needs to be accomplished.
I think the industry is actually wonderful. The skill sets in it are something to behold. Buildings are amazing. The infrastructure that is designed and put in place on a worldwide basis is fantastic. I think the one big change that we need is not necessarily is what people do, but possibly how we do it and when. The biggest difference I see in our industry compared to others is this concept of as-built. I can't imagine an as-built airplane. If we had as-built airplanes, there would be a lot in our backyards and we wouldn't like it. So I would say that we really don't need to change the workflows or the skill sets. We just need to move away from the concept of as-built and we build to design, which means a much more significant collaborative effort at time zero, because that's where the money That's where the margin's determined, and that's where the success is determined a long time before anybody hammers a nail or pours a piece of concrete or starts digging.
Was I supposed to say we don't need architects anymore?
I'm open to this, certainly, this discussion too.
Yeah, but let me
Yeah.
comment. You said you used the word as-built, and I think from an industry perspective, especially with industrialized construction, we're getting to the point, and this was the case at Icon, it's certainly the case at Ghost Factory, that the G code is really your as-built, and you've developed your as-built. I'm not talking about mechanicals, but like structure here. You've developed your as-built in the workflows that happen prior to actually execution. And it's because my machines at Ghost Factory deliver the quality that we tell it to, as long as it's set up correctly. The robots at Icon delivered the wall system like precisely where it was supposed to be. And so I think that there's a lot of opportunity for us to drive the quality of our buildings back to the left and into the design side of the equation, and less of let's figure it out in the field and then draw on a piece of paper what it actually is. As a builder, I was always tired of being told, figure it out in the field. And I was like, no, let's figure it out before we get there, so we stop wasting time and stop it with the RFIs and stop it with the change orders. So that's what we try to accomplish.
I mean, both of those comments kind of point towards, and people often don't want to talk about tools, like the way that we work, because, I think there's plenty of owners too that we see, everything's BIM. You're doing it in the model. Building information modeling, everyone's doing BIM. It is in 3D. But there's some interesting, are we using the right tools, or what has been the barrier for this? Because to Walter's point, the as-built, there's no as-built. The design is digitally represented. That's how you do the simulations. That's how you understand the quantities, the production. That's how you then generate the G code that then produces the pieces of this. And what was interesting, we was working with a friend who's an engineer and doing work for a large aerospace company, and they build, that's their domain expertise. They build incredibly complex physical products. And then when it comes to the building itself, they aren't involved, really. They'll hire design team and engineers and contracting team, and they're using the most robust platforms for robust digital platforms. And then they're considering maybe we need a Revit BIM team. And the idea of this aerospace company, the incompatibility, and I'm not sure why it's so different, of designing a product, modeling it, going through that rigorous process of defining the pieces, parts, why that's so different. When you get to the scale of a building, it all changes. Are we using the right tools?
Well, part of the issue when you consider this industry versus others, we really don't have a gorilla in the room to drive a massive change. If you look at other industries, you have Boeing and you have Airbus. So when Boeing and Airbus decided they were going to model-based design, and you were going to use GD&T, and you were going to do DFMA, which is design for manufacturability, and you're going to do integrated product development, there was no choice. So you, as a supplier or deliverer of services to those industries, you had to change. And in our industry, there are, more than 100,000 designers. There are hundreds of thousands of general contractors. So we don't really have that driving force, from an industry gorilla perspective. And so that's why it takes, I think, us longer to adopt these best practices that I've just indicated. But I do see change. I see developers discussing DFMA now. So I think the train is definitely moving out of the station.
So tools, right? So tools in the industry, and everyone comes from a different part of the industry in here, but tools are what we produce our product with, right? And so there's some thoughts around, what is the product in this value chain that we create, right? And you would say it's the architectural intent, it's the drawings, right? It's the go do this. I would say that that's not the product in my particular segment of the industry. I would say that my code, my G code, is the actual product. You could look at a building or a barracks that we've built and say, like, that shiny wood up there, that steel, that's your product. And it's not really the product. It's the outcome that our process and the tools that we use in that process allows us to perform efficiently and profitably. As an example, we are developing a piece of technology that goes from architectural intent to machine files, to run files, right, and does it very quickly. We put that program together, that MVP kind of the development path for that software 12 months ago. And everybody knows what's happened over the last 12 months. It is a completely different landscape. We are not, sorry for the computer science folks out there, but we are not hiring that tech team that we thought we were going to hire. And things need to move much more quickly now. And so the tools are absolutely changing right now. And I think that if we were existing in the world that even was a year ago or 5 years ago, we wouldn't be able to keep up with what's happening, because compute and the movement, the speed of which business is happening now needs to happen a lot quicker. As an example of this, we had a task order or purchase order from the Army back in February, and they said, Icon was building these 10 barracks and out in El Paso. We need you to do the framing, all the interior walls and the roof trusses, but we need you to do it now. And here's a set of drawings, but we need you to move and actually start executing, because your period of performance is 6 months. So within 10 days, we lifted up our factory from here in Austin, we moved it out to El Paso, and we dropped it. And before we didn't have plans when we were going out there. We had a concept drawing, but we had to put the engineering through an approval process, get that approval process into machine code. And those of you who run machines, you know that there's a QC process that you have to go through there as well. And we had to do that all within that initial 10-day period of time. We would not have been able to do that a year ago, right? And so we were able to move our factory from Austin to Texas, and within 10 days we were producing trusses for these barracks before we even had all the truss plans. But it was like segments, and so we had to really change the tools and the tool set and the workflow that we were using to keep up with the speed of the demand and speed of the requirements. And we ended up 10,000 square foot barracks in 10 weeks for the Army. And that's like, good luck doing that a year ago, or even 18 months, or even 8 months ago. But that's where I think when we talk about, are we using the right tools, I just have no idea, because the tools are changing so fast, right?
So I'd like to comment just a little bit on tools and workflows. So Vaughn this morning framed the importance of design. So I'll frame it just a little bit different. And this comes from a CTO of Hewlett-Packard Corporation. So the design is worth 10 times the method or process, which is worth 10 times the effort of the labor, meaning there's 100-to-1 leverage to do things at a low cost, at a producible level at the design, than there is the poor guy doing the work. So there are tools out there that make that possible. Autodesk has a great three-dimensional tool that largely eliminates setup. CATIA 3D is another one, and it handles these interfaces between design and machine interfaces automatically. You can create BOMs automatically, indentured bills of material. So what's the ultimate goal? The ultimate goal for a manufacturer is not mass production, right? It's actually all about mass customization. How do you do mass customization? Ultimately, it's the elimination of setup. If you think in the limit, if there is no setup, it doesn't matter if I build 1 or 100. What's one of the biggest drivers of setup? The engineering design. So when you have a design where somebody has to go out and then create a BOM, which now it's no longer closed loop, right? No longer closed loop from womb to tomb, who then hands it off to someone who has to figure out how to build it. That is 2 different levels of setup that could be designed with current existing tools. So that's where I think all the money should go today, is in this upfront process to eliminate setup in the factory and in the field.
And I mean, along that point, I guess it's interesting to understand, I mean, you would think contractual models have to change, the value propositions have to change. The idea, again, this kind of sci-fi idea, the tools are, technical digital capability is changing very quickly. And for those that have run prompts and starting to understand the kind of the MCP, where we're truly kind of creating a natural language way to interface with 3D modeling. It's nascent stages, but you can see this working. Is there any right now? It seems that a lot of these issues in the delay time is in the abstraction, taking design, the abstraction in that to then build a set of drawings, the deliverable, typically the set of drawings, or even a Revit, a BIM model has a ton of abstraction in it. It doesn't have offsets for bolts. It doesn't have notches. It doesn't have the instructions in it. Is there, and I guess, why aren't we able to one-to-one evolve our designs in collaboration with domain expertise, manufacturing and engineering? Why aren't we able to discretely define every piece and part? Is there any would there be any downside in having that information? But why aren't we operating at that level of fidelity?
Well, one of the reasons why we used cold-form steel as the foundation for the things that we build at Ghost Factory is because you can apply a piece of data to every component. And so we can determine whether your design gets translated into G-code correctly, runs our machine, and then actually gets produced well. And then we can adjust to make sure that your design for the future is better. So we're compiling data. That is an important part of our thesis around how we're going to build better buildings and more quickly. That piece of software that I just referenced, it is built. It is designed to go from your architectural intent to my G code in an hour, and that includes QCing of the clashes and the things that went wrong. And that truly, like yesterday, I was in a session, and you probably all heard it, where they were talking about it takes us 8 months to go through that process to get ready to build, and then it takes us three weeks. So you have to have this huge pipe of work that you're doing. But if you can take architectural intent and turn it into run files, assembly instructions, stacking and packing for logistics, and then installation instructions with a feedback loop at each one of those points that goes back to the original design, then you're reducing that greatly. And that is happening. Right, so that is happening. So, and who knows what we'll be able to say 12 months from now to the next version of this. So I think that is drastically being reduced.
So I'd like to build on Spencer's theme a little bit, but look at the human interface. So I do think we're making good progress, especially when we have machine interfaces, because let's face it, a robot can't work without accurate data up front. It'll produce exactly what you say. So let's move it to the tradesperson. So what do we need to think a little bit different? Everybody in this room is in the information business. Most of our costs in our company is in information, much, much more than the cost of the building itself. So I have a simple mathematical formula for you. IU squared N. Imaginatively understand users' needs. So this, again, you'll hear me talk about this over and over again. I blame engineers for all the problems in the world. So, and I know people don't like to hear that, but I've worked with vice president of engineers and CTOs, and I go, the root cause of all the problems in my company is you. They never like that, but that's my belief. So IU squared N again, imaginatively understand users' needs. In our industry, a lot of drawings today are still 2D. How many people in your factory can translate a stack of paper this high into the 3D world? I'll bet not many than above 20%, if you're lucky and you have a really good team. It is very, very difficult for people to flip through drawings that engineers that do this work take for granted and go, oh, page 1 is the interface for this particular element of the workflow, and to connect those dots. So right out of the gate, one of the biggest changes we can make is to start using 3D models. Believe it or not, 90% of the workforce can understand the routing of a pipe in 3D. ISO drawings, sorry, they don't get it. So again, back to the engineering problem, imaginatively understand all users' needs. And that includes the purchasing department, that includes the guy building it, and in Spencer's case, the machine interfaces.
And I mean, I can say from past experiences where because I mean, some of this is automation. I mean, I think to Walter's point, and it was a bit of a loaded question. Technology isn't the barrier. I mean, we've got incredible compute power. We've got increasing ways of user interface with compute. We can model everything. Industries are doing that. This is embedded. It's human. It's behavioral. And it's a lot of it's the contracts. It's the relationships of how it's set up. We have had experience designing, understanding the parameters of the materials and the build, and automating that into fabrication tickets, into G-code, into this. I don't think the future of architects is producing fab tickets or producing machine files. That was something you do as a sort of stopgap to sort of bring up the capabilities of the supply chain you're working with. There's no business model for that right now in the way that it's set up. We did not receive the commercial reward for doing that. And I don't think that that's how it works. I think who owns the process of applying systems to the design, I guess, is a question. And then it comes back to sort of education. If it's just it's a lack of, we're not training people, or we're not training owners to kind of demand that, because the owner wants a building. Who sort of owns this technical proficiency, and how are we teaching the next generation to engage this way?
You want that one?
Well, I would say all the stakeholders own it. So I don't think there is one owner, and I don't think that's unique to this industry. It's the same in the aerospace industry, and it's the same in the automobile industry. There are more than one stakeholders. I heard a comment the other on one of the presentations. Someone said, "Well, the car guys own all the design." Well, that's not true. Car may own the overall design, but there are many elements in a car that they absolutely outsource, and that IP is owned by their supply chain. So that supply chain obviously has a common goal, which is to make a car as awesome as possible at the lowest possible cost. So I think that it's the stakeholders in general, and I think it's just, again, our industry is fragmented, but more and more people are starting to put their hands up and say, yes, I'm working with architects today, and we're talking about we need an indentured bill of material from somewhere. So you guys are either going to take that on, or we're going to take it on. And so it's a negotiation back and forth about, you'll do the bombs for this, and we'll do the bombs for that. But the ultimate goal is, again, we want to use our imagination to understand users' needs. We want to eliminate setups at every step. And as a team, it's doable. So I don't think that those roles have to be rigidly defined, that, the architect does A and we do B. But across all stakeholders, including owners, we have to agree that this is the way of the future. And collaboratively, we can get there. And it's done again. We're not inventing anything new here. This is done in industries all over the world.
Yeah, my perspective on that is just like you wouldn't want a developer coming to you with a piece of paper and saying, draw this.
Yeah,
draw this for me, right? As a manufacturer that uses technology to build the components of a building, I want to be able to define means and methods a little bit, right? I want to be able to say, especially to the structural engineers, to the architects, like, we are going to meet your intent, but there's a recommendation that we have based on our running of the files. We'd like to build it this way. And as long as we've got a good feedback loop and everyone's open to that, the idea is not to over-engineer, but to engineer correctly, because that makes projects more affordable for everybody, makes housing more affordable, makes projects for the government more affordable. So I'd prefer to have agency over the files that create the components, that build the assemblies that ultimately are the buildings that we produce. We are the translation layer from architectural intent to how does this actually get built in the field, in the projects at least that we're associated with.
Yeah.
And one more thing, just to build on the ownership. So ultimately, if you look at modern tools that are available today off the shelf, for example, using imaging technology or laser technologies to inspect this room, So that inspection process is doable. We could buy that if we have, again, the design tools that are accurate and enable that workflow. So we could literally put a laser here and make sure that all of those beautiful rings up there are in the right place. But again, I'm going to put the pressure back on the design teams, whatever they are, that they have to have that dimensioned and those GT&T accuracy level to make those workflows possible. But they're off the shelf today, and there are people using them.
Yeah, we use LiDAR to scan all of our slabs and all of the hot rolled steel or HSS that goes in before, especially if, in the Palisades in the recovery, there were many customers who came to us and said, we've already got a permit for wood, our foundation's already in, can you do something with steel? Because we don't want our house to burn down, right? So there's that whole thing. And so what we would do is go out and LiDAR where are the through foundation, plumbing lines and where's the steel? Because precision is very important in cold form steel, especially when we're building either near site or off site and shipping materials in, which was the case initially in the Palisades. That LiDAR allows us to see the deviations from the architectural plan or the structural plan and also identify those locations where there's going to be conflicts with our wall panels and trusses or floor joists, and allows us to do what we call snap to. So we snap our 3D model and the design to those deviations from the plan, if you will, and allows us to manufacture to the site instead of, there's always that conflict. Whose fault is it, right? Like, yeah, you didn't put the foundation in the way it was supposed to be. I don't know if everyone's ever come across that, but there are times when that works, and there's times when that saves a lot of time, effort, money on site. There's times when it's not possible because we are, like right now, we're building a facility for the Marine Corps in Virginia, and I don't know if the concrete's been poured yet, but it was supposed to be poured for the footing today, but we're already done with the walls, and we're working on the roof. So like that's not a foundation that we're going to be able to influence. We're able to influence the installation. We're not able to measure the perfection or imperfection of that foundation and adjust our model against it. So again, the tools that are already out there, it's pretty fantastic with the precision that you can get with them.
Yeah, it's and again, I think we've had these kind of case studies. You have these moments that you can't unlearn, that that it works. And there was a situation where we were delivering the manufacturing files for the enclosure of a building, and we're working on overseas. And we know that it's local labor. We know the tolerances are going to be, there's no specialty equipment. There's going to be tolerance issues. And the solution to that was we will have the site scanned progressively. And before we define or lock the kit of parts in, it's easier for us to adjust the digital files to accommodate the as-built condition at that stage, and then produce those, which is mass customization. I mean, we're producing these files, but it's only because that infrastructure was set up to be nimble and react quickly and then automate a huge amount of production. So if we scale this and really understand the life cycle of a project, this idea that there's a persistent environment where design happens, we do our three-dimensional composition in a lightweight format. Everyone has their eyes on it. The owner can see it. They're watching the product be higher definition. The general contractors are understanding. Well, in fact, in certain ways, that wireframe, you start to look directly at the trades, which is where this gets really interesting. I mean, it becomes a live, very low resolution version of the project, a wireframe that you can host systems on top of, and you could competitively bid those systems. So Spencer could come and say, I'm going to do this with the light gauge frame. Someone might have a 3D printed solution. You could host those things, have real-time value and time associated. That has accountability, and you could start to lock the definition of the project in. While you're doing that, everything has accountability in terms of obviously cost, but larger chunks take longer to move things. So the GC looking at this, understanding the logistics, facilitating the logistics, you're defining the project as many domain expertise, but in one environment, and then that thing becomes the resolution, becomes the kit of parts that you then execute. We've seen that in scopes of work, and it really works well. What are the barriers to, I mean, is that too sci-fi? I mean, understanding contract models, education, what are the barriers to, is that a silly idea? Or
No, I think you're talking about the very far right end of the delivery of our projects. And that's something we haven't talked about. But everyone in this room, if you're doing industrialized construction, doesn't matter whether it's volumetric or 3D printing or panels or on-site or off-site, whatever you want to call it, I think the entire goal is that we're all trying to address you said the trades, right? A labor issue. And so I've had this conversation half a dozen times in the last week. So we're talking to the federal government in the Bahamas about sending a ghost factory there because they need housing. And what we can deliver is a high-quality product that low skill can assemble, right? These are folks that if they have a screw gun and know how to line up two pieces, they can build a beautiful structure, and that's something that's valuable to the federal government and from a job creation perspective. Same thing in Venezuela, like talking about going down and rebuilding houses in Venezuela. The fidelity of the model of those homes up front, it doesn't matter what we run into down there, as long as we have the basic skill set, we can deliver a high quality product wherever we go. And I think that's not sci-fi. It is connecting this workflow, especially digitally, and making sure that we understand in advance where the friction is, and we address that friction. And I think that's something that we all should be very focused on is delivering that high quality product in an environment where we can use lower skill.
Yeah, I think this is a very complex topic for me in this industry. And part of it is driven just by the nature of tolerancing itself. So our industry, our tolerances are fairly wide open. You can go to almost any building I've been to and you can see visible error. In other industries, measurement is a problem. It's measurement error, it becomes more a headache than just the physical act of getting a dimension, because tolerancing is so tight. So the model-based world eliminates a lot of those problems. It eliminates upside-down tolerancing, which I'm sure, I don't know that it exists often in this industry, where the tolerances at the end item are impossible because the tolerances at each of the subcomponents adds up to a greater band, greater dimension than is required at the end item. That's a very, very expensive process. It exists a lot, and how do you solve it? You solve it through sorting, which is very expensive. And again, sorting is setup, which is very, very costly. So with GT&T, a lot of these tolerancing issues go away, model-based designs. You can't, in a model-based world, you can't put a vent or a pipe through a vent. The drawing technology won't allow that to happen. It will block the designer from doing that at time zero. So these are the types of things that where this industry will move to. It will, again, eliminate setup and make it much, much easier for people to build these products going forward, and eliminate these upside-down tolerances and interference fits that seem to be ubiquitous.
I'm laughing a little bit here because we're talking about AI and we're talking about models in 3D and I just had this experience. There's no removal of humans right now, right? Like you still have to have a smart person with eyeballs looking at something and making sure it's happening correctly. We just got a phone call last week. We're building a house in the Palisades. Along the back wall of the house, it's the wall panel sticks out 1.5 inches. It's like the foundation was right, the wall was right. What happened? Well, we hired a new assembler, and they were responsible for all of those walls, and they used a standard hex head screw on the side of the panels instead of a modified truss head screw. So it wasn't flush. It stuck out 1/4 inch, and when you compile all of those errors along the back wall, it's 1.5 inches worth of it was wrong, right? And so there's you build in a factory, we build in the field. It doesn't matter. There's still humans involved in that whole process.
yeah,
So I think that this issue is ubiquitous. Just give you a case study. I worked in the aerospace industry. We made things that would fit on this desk that sold for $100 million, maybe 2 desks, one of them at a time. And we were bought by General Motors making cars. And back in the day, we joked, we said, here we are, the leader in technology, been bought by someone who builds average cars. How is that going to work? So obviously, in our industry, they came along with this concept of lean manufacturing. Lean, statistical process controls. And you can imagine what our genius engineers and our scientists and our company said, we don't need no stinking SPC. Lean, well, who cares? We make one. What does lean have to do with aerospace? And what happened was, of course, the owners drug us into that future, period. So unfortunately, I work in an industry. I came to work in our factory. No one in our company had ever heard of statistical process controls before. No one, period. Not true, one guy. And no one knew about lean or the concept of lean. And so my answer to this is that you're just going to have to grind through it. The only person who likes change is a baby in wet diapers, and they cry about it. So that's where we're at. But it will happen because competition is going to force it. Spencer's already doing these things, so he's going to leave us behind.
No, I have an answer for you. I really do. I mean, definitely. Were you done?
Yes.
Okay. I would start by, there's two things. I would start by saying we are, as an industry, at the right point in history right now, and I'm living that. Like, the people accept the alternative means and methods of industrialized construction. Department of War, Department of Defense, whatever you want to call it, the Pentagon, issued guidance earlier this year that said, hey, when you go out to build a building, you need to explore, advanced construction methods first. Like, you need to do that first. And what we are seeing is that there is an upswell of folks that are interested in using some sort of technology because they know that costs are too high and it's taking too long. And so there is this, and that should be good news for everybody, right? Like, there is this tailwind that I would say that we all have as an industry of people starting to accept this more. So let's take advantage of that. To answer your question very specifically, what do I think is inhibiting the broader world from taking up industrialized construction? It's exactly why I formed Ghost Factory, right? And we studied. I mean, I studied people in Australia, Europe, the United States, and I was a logistics officer in the Marine Corps, so I look at everything from a delivery perspective. And I believe logistics is the biggest problem, right? I had the largest cold form steel manufacturer in the country at my facility a couple days ago, the one here. He was telling us about one multifamily project that he built and had to ship halfway across the country. It was 165 18-wheelers to ship his panels. This wasn't volumetric, this was panels. And so the reason why he was at Ghost Factory was because his logistics costs and his logistics challenges were outweighing the $250,000 in dumpsters that the developer didn't have, and the damage that was happening was like half the country away if you needed a new panel created. So from a logistics perspective, that is the solution that we are chasing, right? Is we go to the point of need, we adjust the building as we find quality issues that are coming up. An example, the 10 barracks that we did, we built the first barracks and cleared right through the 10th barracks, and we built the 10th barracks in a third of the time that we built the first one. It's because we were there on scene as the manufacturer saying, that doesn't work well, let's adjust the code, right? And so how do you get things to the Pacific region? It's hard to ship a lot of material there, so go dense and build it there. That's our theory, at least.
I am curious, a lot of this, in automotive, things like this, the margins are tight. Those things are engineered and they go for long production runs, but they are, these buildings we're in are not Swiss watches. There's a lot of tolerance built in, and effectively, and I don't want to grossly oversimplify it, but majority of it are sticks and sheets is what we make, and some custom components. There's a lot of it, and they weigh a lot when you think of it in aggregate. But I wonder if we become precise around if the components we build, the level of fidelity we're coordinating building around, the components themselves become machined. And I think we can debate whether, the frame CAD or the steel rolling machines or water jets, don't care if they cut one or, 1,000 of the same thing or 1,000 slightly different things. If we really get into the precision, if we build these products through manufactured pieces, do we believe that there will be significant return? Like, can we build buildings cheaper than we're doing it now? Will we see that? Is that what impact will that have on
I mean,
costs?
there's just no question. There's no question, right? We will build buildings less expensively because we will modify, we will run those clash detections, we will understand those errors. That software we were talking about, like, it's a compiler, right? So every mistake that was made in a design from the building we're building today, every building we build in the future is going to learn from the connections or the way that we built a specific header or a door. That's 1% better. You know, every project, maybe it's 1% in installation speed, 1% in assembly speed. There's no way you don't, when you take out error and when you define how to build a building before you actually build it, you reduce those change orders, you reduce that, you know, and when you take out 165 trucks of diesel fuel to build a building, that's $500,000 right there, or whatever that costs, right? So yes, I believe that we are on a path to building faster and less expensive, and frankly, a higher quality building.
Yeah, I agree with Spencer. There is no question. The factory-produced product is going to win for lots of reasons. Just workforce alone. So I have a team of people. I keep the same. We have a good company, so we don't have turnover. So I have 98% of my people have been in the same place for a decade. They really know what they're doing. And if you look at a site build, you may have, John is your plumber today, and in the afternoon you may have a different guy. So the workforce changeover alone, working as a team, is a huge disadvantage for site versus the factory. Our ability to do lean and control destination pairs, right? What's one of the biggest wastes? Lean 101, elimination of waste. What's the biggest waste? Probably in construction, walking, looking, searching, not adding value. A factory can drive to the lowest cost of earned value added. We can put product and materials right next to the point of use, like the operating room strategy. That cannot be done in a site job. So I think that, yes, it's going to go that way. Doesn't mean this building may never be built in a factory, but certainly a large percentage of them will be done in a factory. So if you look, I like that because this is something I'm very passionate about. So, the cars are more expensive in relative terms. There's no way. You look at what's in a modern car today, you have a supercomputer inside of that thing. I have a stereo, I have what is it, a Mark Levinson stereo system in there. It's better than the thing in my house. They're infinitely safer. You can crash these things at, I don't know, 70, 80 miles an hour. Actually, Formula One, they can crash at 170 miles an hour and people walk away. So it's a completely different product. So yes, if we were building a Corolla 1962 version today, I guarantee you it would be less than half the cost. And it's the
80s,
same
there were
thing.
lemons.
Moore's law sort of applies in the automobile industry. So everybody knows Moore's law, right? So, you just say the cell phone today is more expensive than the brick 20 years ago. You literally have a supercomputer in your hand today. So
I think from a building code perspective, though, like, you can go anywhere around Texas and you can see a 2x4 wall with tar paper up and then siding on it, like, right? And so you can spiral down, right? You can go for the lowest, but I think what we're able to do with automation manufacturing is build a higher quality building at a better price, right? So, and in like for steel, for example, it's not gonna burn the house. Our marketing line in the Palisades is your house won't burn your neighbor's house down, right? And that's like half joking when we make sure that they've had the therapy they need because it's a really serious thing. But like, people understand that, and it's not about the cheapest, right? It's about what level can you deliver at the best possible price. Well, I've built with modular, for like volumetric modular before. This is the first homes that I ever worked on. Where do I think it fits best? Well, we say at Ghost Factory that, Ghost Factory is built to go to hard places and do tough things. Like, we're building a 6-star hotel in the middle of 1 million acres in Utah. And it's not easy to get people or materials there, right? And it's logistically difficult to get into the hills. I think there's, again, a logistics component of it. It's going to be hard to ship big modules to the middle of nowhere in Alaska, or take them down to an environment that's not secure in Venezuela or into the middle of the Pacific Ocean. There are some constraints there, my system doesn't work in certain areas, and my system does work in certain areas. So I don't think that it's a binary answer. There's clearly times when it works for volumetric, given the history of the industry.
Yeah, I think the market's going to sort it out. At the end of the day, it's like, any manufacturing businesses, logistics is a driving force. The customer base is a driving force. So you're going to put factories where it makes most economic sense. And obviously, the cost of transport, the ability to get talent is going to be a driving force. So I don't think that it's going to be a single solution. I think the market's ultimately going to drive it. And you're going to see work distributed in just different ways today. And maybe we'll ship certain items across the country and other things, it's just economically infeasible. We're shipping air. Air is expensive to ship.
I didn't say that. You did. And that's a big thing. Yeah, I think that I had a thought before I made that stupid joke.
It's okay.
I don't know what it was.
We're not joking guys.
Yeah, no, I don't know what it was. So never mind. That's good.
Well, yeah, and we're out of time. I appreciate
Yeah,
your
yeah.
guys' time and insight, and yeah, thank you all for.
Yeah, really enjoyed talking to you. Good talking to you.